Hunter Leath is today's guest, and he is the CEO of a company called Archil Data. They are 1 year in, they went through YC, and they aim to be the universal storage engine that sits on top of S3. So it sits between you and S3, and then it pretends to be a real disk that your ephemeral containers can talk to, that your Lambda functions can talk to, that your regular old servers can talk to. And what this does is this allows you to have infinite storage in your own S3 bucket, but still be treated like a local disk. And if you talk to their clusters, they've got a whole set of SSDs in the middle that intelligently speeds everything up. So we talk about the whole thing. It's extremely interesting. You'll hear me getting it along the way. I start out not getting it at all, and by the end, I'm pretty much sold on it. So I hope you enjoy this episode of Database School. I'm here today with Hunter Leath, the founder and CEO of Archil. Hunter, thanks for being here. Do you want to introduce yourself a little bit further?
Sure, yeah. Thanks, Aaron, for having me. I started Archil about a year ago to kind of transform cloud storage into something that made more sense for developers by taking S3 buckets and turning them into infinite POSIX-compatible file systems that allow instant access to massive data sets. But I'm obsessed with the space and delighted to be talking about it.
Yeah, so this is interesting because what caught my attention was it was very, I guess, very like circular, self-referential. I spend time on Twitter and I spend time on Hacker News, and I was on Twitter and I saw you tweeting about Hacker News, and I was like, what's going on here? And you were talking about running SQLite on top of S3, which Hacker News said was impossible, which, you know, that's about par for the course over there. So that's what caught my attention. And I think I replied directly and was like, can we talk about this on the show? So that's kind of what I want to talk about, is like running the SQLite on S3, and that can maybe lead us into the broader, like, what the hell are you guys building over there? But give me the 1 or 2 sentence pitch on the company. Like, what does this enable? What is like the vision? And then we'll go into like this specific implementation of running SQLite on S3.
Yeah, I think that's great. I think that the hardest part of any kind of application development is actually state management, which I may say because I'm in storage and I'm a little bit biased. But traditionally, the issue is that developers only have 2 options. They have S3, which is shared and can be accessed by all of their instances, but it's super slow. People like that it's super cheap. People like that it's pay-as-you-go. And then this other option is like either EBS, any kind of networked block storage, or if you're like Sam Lambert, you know, the NVMe device is attached to the instance, right? And these 2 worlds both have pros and cons, but there's no way to join them. And what people really want is a simple way to keep state somewhere very fast so that it's accessible to a lot of instances. And they want that to look like S3, something that you pay by byte. And ideally, they want that data to actually live in S3, because developers really want these data sets to end up in kind of a single storage system of record. And so we started the company with the idea that we could join these 2 worlds by building a layer on top of S3 that leveraged, you know, local storage and things on our side to provide a high performance experience that was pay as you go, that would synchronize this data back and forth for developers. But that's really the goal, is to eliminate all of this challenge around moving data and deciding what kind of storage system that people have to go through today.
And so it's interesting to me, being, you know, 1,000 years old now. I remember when S3 like was first coming out, and it was like, oh, this changes everything, right? And so that was like the new generation back then. And now we're like, hey man, oh, I like S3, but we gotta change everything again. And so that's where you come in saying like S3 does provide us all of these great primitives, but it's this big gap, this big chasm in the middle, and we're going to build something on top of that to enable us to like both have the infinite scale, but also have a lot more ease in that quick access. So talk to me about maybe frame it in this. I'm trying to think of the example. Let's do the SQLite one. Like how is your infrastructure? What are the layers? I know it's S3 at the bottom, but kind of walk us through like what is actually going on there and how like transparent is it to me? What are you guys doing behind the scenes? So maybe take us just top to bottom using SQLite and talk to me about the stack.
Yeah, and I think that SQLite is a really good example because there are so many applications that have been written over the past 50 years. And the vast majority of those applications still require that you have a file system to run them on. And when you log in to SSH, you're expecting to touch files and MV files and RM files, which just aren't things that translate so well to S3 as it exists today. And so we see this usability gap as this piece that we can solve. But when we talk about providing this ability to transform S3 into a format that's understandable to Linux and SQLite, I think a lot of people have reservations because they've used existing, fuse tools like S3FS or GoofyFS that like either compromise on performance or compromise on correctness that make them feel like they can't use this for anything real. And so our stack is built around doing this differently. I would say the right way, but again, I'm biased to make
I'll
this
allow it.
make this performant and functional. And the way that we got here was a lot of our team had spent years and years at AWS prior to this working on the file storage services, which are things like EFS, which is a networked file system that functions a little bit like S3, and FSX, which allows people to run NetApp, ZFS, and such in the cloud. And what we realized was that that file system layer is the piece that was missing from these existing adapters, which is something in the middle that has durable SSD storage of its own. And so what we've done is we have a client application that our customers install, which is a Fuse-based mount program. That client application connects to our shared cluster in most cases. That shared cluster has this durable SSD high-speed storage that we can use to cache things coming out of S3 or stage things going into S3. And then beyond that, we are pushing all of that data into S3 in an eventually consistent fashion. But you likely see parallels in this architecture from how things like Neon and TurboPuffer and Databricks and Snowflake work under the hood. And our goal is to just make that architecture generic so that anyone can take advantage of it.
Okay, that is extremely helpful. And I'll repeat it back to you, and you tell me where I completely missed it. So, your customers install something provided by Archil, some sort of client provided by y'all, that then acts as the translation layer. Then they can just write to it as if it is a file system. Good so far?
That's right.
Okay, so they just write to it like it's a file system. So you've provided some sort of translation layer, all standard stuff, and then behind the scenes, that local client, then that goes out and talks to a cluster of compute that is, in some cases, you said, probably most cases, owned by you, probably big enterprise cases owned by somebody else. Fair enough?
That's right.
Okay. That cluster of compute has super fast storage attached to it. And I am sure that you guys are doing tons of intelligent things about what is in there versus what is in S3. And that is serving as like the front door or the blocker to S3. And then behind the scenes, behind that cluster of compute, you're putting stuff on and getting stuff out of S3. So from my perspective as a customer, I'm writing to a disk. I don't care if you keep it in an SSD or if you put it in S3. That is your problem. But I know at the end of the day, I am presumably getting billed by usage. It's going to last forever in S3. It's going to be cheap storage long term because it's in S3. But it's also going to be fast because I trust you all are doing some sort of intelligent optimization to get me the data that's being used most often or most recently. How did I do?
Yeah, that's great.
All right. Okay. So now, what are like, what did you, what is the problem that you set out to solve with this? So you looked around at, you mentioned several that are using this architecture for very specific things, and you thought, hey, that's pretty cool. But what were the specific pain points that you were either experiencing yourself, talking to customers, and then what are customers using it for now? So like, where does this fit in perfectly? Either is it a scale? Is it a use case? Is it some other thing that I'm not even thinking of? Why do people use this?
Well, I think one key differentiator between probably many of the people that you talk to is that we care deeply about unstructured data. And so if it goes in a table, generally people are using something else for it. Unless, like we said at the beginning, they're running SQLite and they want to put SQLite somewhere where it can be accessed by a bunch of different servers. And so we often find that the use cases that we are helpful with are ones in which people are dealing with image files, video files. That can be like large-scale genomic processing. That's a lot of AI model training and inference these days. But it's also things that require, real file system semantics, like if you're running Git, which means that we find that we have a lot of customers in the CI/CD space who are traditionally underserved by shared storage because it's too slow for their needs or too expensive for their needs. And we're also seeing a lot in the agent space that's popping up around Git and small customers and using files. So it's a super broad set of very exciting use cases that is hard to pin down right now.
How do you handle, let's take Git or SQLite or something like that. How are you all handling like the many small files, little bitty things flying back and forth? That seems to me like it could be one of those instances where it's like, hey, this is good in theory, but in practice, it kind of breaks down.
Well, I think there's two reasons why small files are like an interesting thing to talk about. One is that if you are someone who has used an NFS server before, at any time in the past, and you've tried to run Git on it or anything that has lots of small files, you quickly find that it's just not performant enough. And this was a common challenge that we had at AWS, where customers would come in trying to use these products to do Git clones or compilations or transactional workloads. And the round trip latency to the server was too high such that it could not be performant enough for a production use case. And we've actually solved that by creating our own storage protocol that's optimized for small file writes, that allows us to make it as fast as block storage so that you're not paying this round trip cost for every file that you might want to work on, whether you're reading or writing them. And then I think the second reason why it's interesting is people say, well, if I'm going to Git clone 1 million files, I don't want that to turn into 1 million requests to S3, which can easily be an expensive proposition. And so I think for us, what we want to enable is this easiest onboarding path for people to use storage that would otherwise be really complex for them to orchestrate around. And so out of the box, we do this synchronization to S3. For some customers, S3 is actually too slow for all use cases, or maybe it's too expensive due to the access patterns, like with the small files. And so what we're working on is enabling customers to tell us when they want to opt out of that. And sometimes people will say, I actually just want this directory to be stored on SSDs all the time, and I'm okay paying more to do that. But up until this point, there's never been a storage system in the cloud that you can dump your data on and have a one-click upgrade path to just being on SSDs all the time. So we think it's much easier, even if they have to opt out of some of these pieces that we're talking about.
Okay, so now I have 10 other questions. So let me categorize these here. So first of all, observation. This is not a question. It's like at a conference when it's like, does anyone have questions? And this is not so much a question as it is. Okay, so I've been thinking of this being useful when you want an infinite disk, which I think is true. But I'm just now realizing this is also useful when you have ephemeral storage. So like you're running in Lambda or on, Heroku or something like that, where you don't have like storage that actually sticks around. Then you can just mount your little client and you suddenly have storage that sticks around from either container to container or Lambda invocation to invocation. Is that right?
Yeah, and I think this is what's so hard about when people ask like what problem we're trying to solve, because it is like fundamentally, I believe that the building blocks in the cloud are wrong. And if we're successful, we want to be the default choice for all new applications in the cloud. Because you're right, if you're in a container or a serverless function and you need storage, we work for that. If you don't want to worry about capacity, we work for that. And we do this all at the same performance as EBS and the network block storage that people expect today.
Yeah. Okay. Okay. It's just, I'm starting to understand the expanse of the scope, and it is vast. You mentioned something in passing which should not be passed over, is that you wrote your own. I forget what you called it. Your own schema, your own protocol, whatever. Talk to me about that. Like, what are the pitfalls of the former protocols, and how did you all fix them such that you're not, I guess the SSDs block the million requests to S3, but what is it that allows this to be more performant over the network?
Well, so if we look at the part of this that's using our protocol, meaning between the client that our customers install and this shared cluster of storage, what we're doing is we're exposing a file-based interface, meaning create file, delete file, but also rename, link file, attributes, all of these things that you would expect from a POSIX file system. And in order to satisfy that interface, there have traditionally only been two protocols that matter in the last 10 years, let's say. One is NFS, which is what we used at the Elastic file system. And the problem with NFS is that it has all of these hard semantics optimizing for situations in which multiple people are writing to the same piece of data. So as an example, if you're connected to a file system and I'm connected to a file system and you create a file, NFS's semantics mean that if I try to create that same file, it should fail. And as a result, every time we both create a file, it has to go to the server so that you can decide which one of us wins. And this is a huge problem for performance and not something that you deal with on block storage, where all of these conflicts happen in the kernel. And so it was really important for us to design a protocol that got around that so that people could use things like Git and get the performance that they were expecting from just their single server use cases before. The second protocol that matters is Lustre, which you often hear like in HP, like high performance computing, national labs, and more recently in AI training. And
I'm not going to pretend like I've ever heard of that in my life. You said it's called Lustre?
Yes, Lustre.
Okay.
It's designed for like highly parallel, enormous workloads that need to be transferring terabytes per second of throughput across the network. And the way they do this is by spreading out the load of the file system across a large number of front-end servers, which NFS doesn't support. And so our protocol mashes up these two things so that we can get the fully parallel scale out performance of Lustre to serve millions of IOPS and terabytes of throughput per second on the file system with the semantics of NFS, with our additions of being able to do much faster reads and writes because we are not optimized for conflict avoidance like NFS is. That was long-winded.
This is the long-winded podcast. That's what we're here to do. So keep being as long-winded as you want. And I'm realizing now that I never thought I knew very much about storage, but I'm realizing I know even less about storage than I thought I knew. So this is extremely helpful. So talk to me about once it reaches your cluster, and let's say that it goes all the way through the SSDs out to S3. What are you writing to S3? Is it like real individual files that the client or the that's a confusing word, that the user gave you, or are you doing some sort of packing and throwing it on and keeping a metadata of where everything is? Like what's the semantics of it behind the cluster?
This was super important to us as well for a user experience point of view, which comes back to the existing adapters that people know about are either something like S3 mount point, which is something that AWS puts out, which is effectively read-only, doesn't support all these applications, but is able to work with the data that's in S3 in its native format. Or they know about things like JuiceFS or ObjectiveFS, which provide something that's fully POSIX-compatible. You can do renames, you can do hard links, but they're writing data into the bucket in a format that can't be understood. And then there's some stuff in the middle that basically just gives up correctness as the way to get around this. But we achieve both of these things, which is that we're fully POSIX compatible, but at the end of the day, what we're putting into your bucket is the actual data. And the benefits of that mean that you can create a bunch of files on the file system, and then you can process them out the back with S3 if you need to serve them with something like CloudFront or run Object Lambda on them or other downstream tools that might exist. But you can also connect us to a bucket that has data in it and just start to use it as a file system, or even, do it in both directions.
Okay, so I'm updating my understanding in real time. You're writing, so I send it to you, yes, because you've got the clusters and the SSDs and you're doing all the magic, but then you're putting it in my buckets.
That's right.
I see. Okay. So if you put some sort of garbage 10 gigabyte file in there that I got no idea what's in there. It's half of every file I've ever created, but not the whole thing. That's useless to me.
That's
so
right.
You're putting actual files in my actual bucket such that I can, like you said, serve them out over a CDN.
Yeah, that's right.
Okay. How are you as a company not hitting S3 limits? Because I imagine you're just hammering away. Is that because you're caching so much at the cluster level, or how are you making sure that your throughput doesn't get limited beyond good relationships at AWS?
I think it comes back to this ability for us to offer customers incremental performance at the click of a button, which is that we think that for most use cases, this is not a problem. And most people would like to have that data in their own S3 bucket in its own format for them to use. But if you start to find that for whatever reason, this is not performant enough because the kinds of operations you're doing end up queuing on the S3 side, or S3 starts to push back on us, we give customers that ability to say, just keep it on SSDs. Forget S3, keep it on SSDs. And we can continue to do that magic for you without the synchronization. We're investigating. Some people care about getting their data out in almost like a tar.gz file, and how we might take directory structures, which they care about, give it to them in their S3 bucket in a format that is still usable to them, but do it in a way that's maybe less pressure on the backing S3 system.
That's interesting. How much, if any, engineering have you had to do to work around those S3 limits where it says, hey, buddy, you got to slow down, man? Is that a big, was that a big early thing and it's not anymore, or was that ever a thing?
I think like you can think of our product as almost like an entire system that's designed to work around S3's limits. And so our goal is to obscure as much of that as possible from the end user so that they don't
Oh, for
have to
sure.
worry about it.
Yeah, I'm thinking about how much you have to worry about it. That's my question. A lot?
Yeah, I think so. And this is why like I always recommend people farm this out to an outside company. It's similar to like a database. In most cases, it's better use for you to use a database that exists than to build your own. And we think for this problem space as well, it's better for you to farm out those problems to a company like us instead of having to go and deal with them yourselves. And so we have finely tuned S3 clients that we use in order to handle and work around these issues. We have lots of queuing set up in our system to try to decide when we send what to S3 to try to alleviate the pressure on it. And all kinds of tricks like this to get around them, as well as giving people this kind of opt out that we talked about.
So I can throw my gigabytes over the wall at you, and you got to figure out how to slow it
That's
down
right.
from getting to S3. Ah, that's the dream. What are some of the S3 primitives that have either made your life easier or harder as you're building this out? And does it currently support other block storage with S3 compatible APIs, or are there primitives that other folks don't implement that are keeping you off of there for now?
No, we made the odd decision as a company to like stay away from anything that Amazon adds to the protocol. And so as an example, we don't use conditional writes at all in Amazon's S3. We don't use I think they have like appends. We don't use one zone. Our goal is to again handle these problems for you so that we can be functional on any kind of block storage that you might throw on us, which could be MinIO or whatever will succeed MinIO,
Right. RIP MinIO.
or Azure even, or GCS. We only require the base protocol.
So can I come to you and say like, "Hey, I want to put all of my stuff in R2 because it has free egress," and you're like, "Yeah, I don't care. That's fine."
That's right. Yes. And so
Hey,
that's
cool.
a super common pattern is like, if you think about it, R2 is the perfect place for all data because there's no egress.
I agree.
If you could have something that was like fast in the data center you were actually accessing it from.
Yeah. So let's talk about data centers that you're actually accessing it from. Um, I could be on DigitalOcean, Cloudflare Workers, EC2, Lambda. I could be on Hetzner if I wanted to spend, $4 or whatever they advertise. How are you guaranteeing that I am not in, we'll say Virginia, and you're in Germany, or the other way around? Like, how do we handle that?
So it is much like, trying to place your database in the same region, that it is super important that the compute that you're using is talking to one of our clusters that's in the same region. Because especially when you talk about hooking something up to the Linux kernel, milliseconds matter tremendously for your system responsiveness. And so, I don't think that we have anything in particular that detects whether or not someone's using it from out of region. That's something that you can do. We've not spent a ton of time benchmarking it, but our goal is for our service to be available in all of the major clouds and all of the major regions so that customers don't have to worry about whether or not we're there.
Okay, there you go. So when I'm standing up my stack, I'm thinking about where's my XYZ database, whether that is, an AWS database or one of these many good providers out there. Where's my database physically sitting? Because that's pretty important. In fact, more important is where's my file system? And so that's just another thing that I'm thinking about now, because of this architectures. I'm thinking, it's not even, gosh, it's interesting. It's not even really my file system. It's where's the compute that's driving my file system, frankly. So I want my database, my main compute that's driving my file system, and my application servers to be as close to each other as possible.
That's exactly right.
And you guys are trying to be in every cloud in every major region so that I don't have to make that trade-off of saying, all right, I'm in Virginia, it's over on the West Coast, I'm hosed. So you guys, y'all have to run a pretty big fleet then, huh?
That's right. Yeah. And so I dream of being a company that is like a real SaaS company that doesn't have like costs and things like that. But unfortunately, we do have to pay for all of these instances that we're running in order to make the service available.
That's gonna have to be the next company because this ain't it.
That's
It's not
right.
gonna. It's just not gonna happen on this one. Okay, yeah, that is extremely interesting. Now, are there um, like I know you said you don't do anything with the protocols because you want to remain block storage agnostic. What about any of these other things that these clouds are doing? Like, I don't know much about it, but what about this S3 instant access? Is that something that you take advantage of, or does that fall into the don't touch it, stay agnostic?
No, I think you're talking about S3 One Zone Express, I think.
You tell me. I mean, that name sounds more AWS-y, so probably that's what I'm talking
We were
about.
really good at adding lots of adjectives to
Oh, dude,
everything, you
it's the
know?
worst. Yeah.
Yeah, so we don't touch that either. I think that this comes back to like how we take these architectures that have been successful for other companies and we make them generic for all use cases and generic to run everywhere. Which is that I know a lot of companies leverage that low latency, high speed S3 in order to make the system work at a good enough performance. But what we've done is we've replaced it. And you can almost think of our compute cluster as doing or fulfilling the same job as the S3 One Zone Express does for many of these people. And we've just built our own place to write data to that's very fast before it ends up in S3 proper.
That's fair. Yeah. So you don't need another layer of fast caching because you own that and that is everywhere. And then you just put it into the cold place. You know, S3 is not that cold. There's Glacier too, but you put it into the long-term storage and you handle the fast access. That's the whole company. So does your, does your purview end when it goes into the client's bucket? So is the only thing, and I say only, with air quotes because it's a lot, is the only thing that you're running the cluster that is receiving and sending data and writing stuff to SSDs, and then you are ending your job when you place it into a client's cloud storage bucket?
Yeah, that's right. And I don't think only is a bad word here because it comes back to the experience that we're hoping to deliver to people, which is that if you don't have our system today, you're having to pay for all of this hot storage, whether it's EBS or local disks, whether or not you're using it. And what we're hoping to do is because our job is just for holding your data while you're using it, we actually only charge you for the data that's active, as we call it, whether you've just written it or whether you're reading it repeatedly through the cache. And if you stop using our system or stop using your data or traffic goes down, everything flows back into S3 and you pay us nothing.
Oh, so this is interesting. Okay, let's talk about billing. So you're telling me, and this is again updating my knowledge in real time. All the data, like we've talked about, all of my data at its final location is in my S3 bucket. What I pay Amazon is none of your concern. At that point, it's my job to pay Amazon, and good luck, have fun. But you're saying as the data either flows through you or is stored in SSD either by function of your cache algorithm or my turning on a toggle somewhere that says store this directory, I am only paying you when you are touching my data.
That's right.
Hey, that's pretty good. I like that. That seems reasonable to me. Is that what you set out with? Is that your pricing structure from the very beginning?
Yeah, we have this like funny thing as a company where we kind of like set out with this plan and we've just been on it this whole time. And so, yes, that's the goal. And we find that because if you're paying for disks in the cloud today, you're probably not storing 100% of the bytes on them that you're paying for. we can be as much as 90% lower cost than many of the things that people are doing today while giving them the same or better performance.
So you're telling me that people are paying for these expensive disks that they're not fully using, and instead, if they put all of that data in cheap old S3 and pay you a little gatekeeper fee only when it's in excess, they still come out way ahead.
That's right.
Hey, that is pretty clever. Tell me, what are the trade-offs of this kind of system? Because so far, I'll say it so you don't have to. It seems amazing. It seems like, hey, I should just use this. There are no trade-offs. So tell me, like, what are the trade-offs? Where does this break down? When do you suggest people take a different pattern or approach, even if for part of a system? Talk to me about like the cold hard realities of trying to do this for 100% of your needs.
So there are basically like two cliffs that we think about. One is if you are doing a completely random read workload. So if you think like true data lake, I have all my Parquet files, I'm going to execute a SQL query against my Parquet files, and I'm going to read a very small amount of that data exactly once, then we don't really help with that because you don't get any benefits by things being on fast storage if you never come back to the same pieces of data that you're touching. And so that's like one set of use cases that we try to stay away from. The other thing is people who have tried something like an EBS or hyperdisk and moved to local SSDs for performance reasons. We provide this same experience as having this networked attached disk. But if you're at the point where you're like, I don't care about the durability, I can manage that myself. If you're doing planet scale metal because you care about the P99 latencies, we're not going to be able to deliver the same latency as something that is physically attached to your motherboard. But we can deliver the same latency as something that is networked.
Okay, I buy that. That seems fair. So you're saying you replace a big chunk of the middle, but something like metal where you need it actually physically attached. And like you said, durability, Planet Scale has to do a ton of work to make sure they don't lose anything. And they have done that work. That doesn't obviously doesn't make sense because they're going from network drive to physically attached, and you are taking over a spiritual part of the market that is network drive. It just looks like it's attached and it's infinite. Is that fair?
That's right. Yeah,
Okay.
but for many of these databases that run in a way that is different, where the storage is detached, we should be able to provide the same performance as like a Neon or a SQLite on EBS.
Yeah, so talk to me about that because that is the that is the hotness, separating storage from compute. A lot of companies are doing that, some aren't, and then everyone fights about it on Twitter. So talk to me about like separating the storage from the compute for like a database. So is this a viable solution for that? And is anybody using you to back their database storage at this point?
I think that it comes back to like this question of trade-offs. And I have thought like deeply about this problem space for I think almost a decade now. And I'm still surprised to see how people are doing things. When Planet Scale came out with Metal, I like thought deeply about this for maybe a couple months. And I eventually pinged Sam on Twitter and was like, I think that you guys have found the optimal way to do this if what you care about is latency. Like there's just no better way to build a system of that nature. But I think that if you look out at these use cases, there are a lot of people who actually care about a bunch of things that are not latency even today. And they might care about things like snapshots or this ability to not have to worry about capacity or the ability to spin to zero or spin up and down really fast. And for those kinds of use cases, I think that we make a lot of sense. And the databases that are prioritizing separating storage and compute obviously have a much easier path to delivering those things than the ones that aren't. And so I don't think that there's necessarily one right or wrong way to do it. But I do think that the vast majority of applications that exist are never going to be rewritten in like this very careful way that PlanetScale has done with MySQL to enable the kind of latency that you would get by having locally attached storage. And so you're better off using something like us for it anyway.
Yeah, that makes sense to me. So we've talked about a lot of the thing that a lot of the like normal use cases that this enables, where it's just kind of like a swap one for one, like take your old, your old limited thing, swap in the new thing, and you're good to go. Are there new like brand new uh ideas or businesses or patterns that this architecture enables? And have you seen have you seen people, maybe your customers, thinking, whoa, I can totally change this thing? Or have you, as you're building this, think, hey, this is a great solution for this certain type of problem? So like, forget, yeah, you got a infinite storage and it's pretty fast. What does this enable us to do that we haven't been able to do before?
And I have been surprised by this because going into the company, I wasn't like shooting for that, let's say. But I think that this whole macro trend around AI surprisingly fills this like demand for us of like people who need to do net new things. And so I think like if you look at the people who are doing training and inference and have run the world out of GPUs, for the first time ever, they're finding that they need to split their compute across all these different geographic locations, but have access to this same set of data. And they need a way to cache that data or access it and write KV cache from all these different places simultaneously, which we enable for them. And then I think on the small scale with agents, you see a tremendous number of people who are trying to build things that work on top of Linux boxes. And when people look at model performance, they are surprised by the fact that models are way better at using the file system than using things like S3 because the training data is just enormous for how to use Linux. And so more and more we see people who want this almost scale to zero storage where I can attach it to an agent, a model that's trying to run commands on a Linux computer, whether they're Git or otherwise, and even attach that to large data sets that might be in S3 today.
Hang on. Okay. So, riddle me this. If you've got a bunch of agents churning away on something, and then, hopefully they're sandboxed, hopefully they go away at some point, new ones start up. This could be a way to give them an interface that they understand, which is the file system, and some sort of like long-term memory where they can put things, and then when they wake up again from the deep sleep, they can just go and like read the disk, which in reality is reading through you to S3, so that not only do they have the most universal interface ever, but they can work in containers and not blow away your whole system.
Yeah, that's exactly right. And this is new. Like
Ah,
I don't think people thought this about file systems 5 years ago, but now it's just this problem that keeps recurring of how do I give this agent a file system in a container?
right. Okay. This is really interesting. How do you think about marketing your company? Because, we've been talking for 40 minutes here, and I think what I thought is not what is right. And now I think all these new things about your company and how almost universal it could be, which sounds really difficult to market. So, how long have you been a company? I think y'all went through YC. Give us the timeline, and then let's end that timeline with how do you communicate this to the market?
No, I think it's very difficult, and as I'm sure like listeners probably have caught on to, there are just so many different things that you can say about this that it is challenging for us to figure out the kind of one line or two line way to describe this to people. We did YC last fall in the fall 24 batch, which would have been September 24 to December
Oh
24.
wow. Okay, that's
Um,
recent.
yes, it's been a whirlwind to say the least.
I bet.
So one year we were able to raise some money out of YC, which was tremendous, and I think our investors are aligned to this universal storage data vision, especially with AI happening, as a path forward for the company to be extremely successful. And I think the way that we think about marketing is it's iterative, which is that we are not going to be legible to all the consumers today. And primarily that's because if you're working on a project, you're often not going to the internet and searching for like storage solutions. You're
No,
probably
I'm sure
searching for
not.
like, how does someone host GitLab and like what are the options there? And so what we're working through now is with our initial set of customers, how do we turn what they've used us for into these case studies and specific examples of applications so that the people who are less interested in the storage world are able to find us and start to use us for their applications too.
Have you had any early wins or glimmers of hope on like, oh, this is a pain that people are experiencing that we fix and we can communicate clearly? And I think it's all three of those, right? If there's no pain, there's no problem. If you can't fix it, that doesn't matter. But if you can't communicate it clearly, then nobody's ever going to find out. So have you had any early ones where you're like, hey, maybe we should, change the H1 to say this?
Yeah, I think that for us, the problem will be that there's not an H1. It is like, which everyone, I mean, investors always tell you it's like a great place to be.
Yeah, I'm sure Gary Tan loves to hear that.
I think that we want to do application specific marketing to the different kinds of people who would be using us because the people who are doing DNA sequencing, for example, have a different set of problems that we solve than the people who are building agent sandboxes. And so when we talk to people who have these DNA sequencers, a common challenge is that they have machines that output files that need to go somewhere that's high performance, but then they have this data team that does not want to touch a file system at all. And how do we connect these two worlds together? We also see, people who are working in self-driving cars and have, or large robotics, industrial robotics maybe is the right word, where there's just a tremendous amount of LiDAR, radar, and video data that needs to go into these models. And the way that we talk about their challenges is different than the genomic people because they just have a volume issue. And so I think like over time, it is possible that we will, and probably preferable that we start to shrink the number of places that we go so that we're not just a single universal thing. But I think that in the fullness of time, my hope is that we can be the universal storage layer for the cloud. That's the destiny if we're successful.
So you've solved the easy part, which is universal storage layer in the cloud, and now the hard part is what does the H1 say?
That's right.
That's what I'm
Yeah.
hearing. That's what I'm hearing. You mentioned pretty early on that in most cases you own the cluster. What are the outside cases where you don't own the cluster?
Well, so I think you mentioned it early on, and you're right, which is that there are some enterprises which have data that is so confidential that they do not want to ever share it with someone who is outside of their AWS account. And this is something that I'm like super happy to provide. It's just not a great experience for them because storage is something that must be clustered to work. And so we don't have this ability to just hand them the number of instances that they need at any given time because data has gravity, we need to move it around, we need to replicate it into multiple services, multiple servers for durability reasons, and then the number of disks you have controls the amount of performance you can have. And some of these enterprises are not cost sensitive, and so that's totally fine for them, but it's not something that I would recommend for anyone who could get away with using a shared cluster. And there are reasons why S3 is so successful because we don't have to deal with these things.
So is this different than, because when you were talking about this, I was thinking about, again, PlanetScale's model where they will deploy PlanetScale inside of, your AWS environment. But it sounds to me like that's a lot more static than what you're describing. So they deploy some fixed number, I'm guessing here, some fixed number of instances that they can, then upsize from the dashboard or whatever. But you're saying that it's the nature of the data that demands certain types of machines and disks and configurations therein that make the whole like, hey, we'll just put a server inside your AWS. That makes that a little bit impossible to do.
Well, and I think that after spending all this time at AWS, in particular one of their shared services, like bristle at this thought of having like a minimum buy-in. And I think that what PlanetScale has done a great job of is figuring out how to give people value at the $50 a month level and at the even now like $5 a month level. And I think that the numbers that we would have for our minimum size would be much, much larger. That's not to say that it wouldn't be useful. And I could see a world in which if everyone has this demand for single tenant clusters, that's something that we could simplify the deployment of those single tenant clusters so it is a point and click solution if we can get the numbers into a place that makes sense for a large number of use cases. But both of those things remain to be seen.
Yeah. Okay. No, that makes a lot of sense to me. So, as we wrap up here, I want to hear kind of where the company's at right now. A year in, you're in a new office that looks beautiful. So, congrats on that. So, where's the company at? Give us a sense of like maybe number of people that are working there, and then where you expect to be, kind of like in the next year, whether that's company or product or just hopes and dreams. And then after that, we can wrap on what you need from the people. So tell us where you're at now as a company and where you hope to be in a year.
Yeah, I think so. So today we have 7 people, including myself. Everyone is an engineer, similar to Modal. Like it's a very engineering first situation that we find ourselves in. I think that over the next year, we hope to grow the company probably to 20 or 30 people. This problem is one that we can continuously absorb engineers into because there is an infinite amount of hard engineering work to do. We have been working with some of the biggest companies on earth in terms of getting this product into people's hands. We've been working with some of the frontier labs, some of the people building like agents and things like this. And so I think that over the next year, I would love to be able to kind of share more about that with people. But it's been like a very exciting journey. And I hope that we're able to claim the title of being this fastest and easiest storage to use in the next 12 months in a way that's like very discernible.
Well, it sounds like it's going extremely well so far. You set out with a vision and you're executing on it. No pivots. So it sounds like it's going extremely well so far. So tell us, tell the listeners what kinds of people you're looking for, what kinds of roles you're hiring for, or how they can otherwise help you and help the company.
Yeah, so the kind of person we're looking for is not a storage person. A lot of people think like, oh, I have to have storage experience. What we care about is distributed systems. So it's all the same skill set of consensus and logs and leader election, all of these kinds of problems that happen in a cluster that we're looking for. I think we have a couple of job recs posted on our site on archil.com that you can see. But if any of this, resonated to you because either you have a petabyte of data that you're struggling to get around to your instances, or you have applications like SQLite or proprietary stuff that requires a file system that you wish you could connect to S3, then give us a shout because we will be more compatible and performant than anything else that's out there. And you can make one of these things today if you just go to disk.new.
Oh, that's great. Oh man, I love that for you. Okay, Hunter, thank you for doing this. Tell the people where they can find you online, and then I will wrap us up.
Yeah, so give me a follow on Twitter, I think, or X. I'm JH Leath, is my handle. And then we also have at Archil Data on X, and we post basically everything there.
Okay, y'all have to follow Hunter. He's criminally underfollowed. I saw the SQLite tweet/video. Immediately thought, oh, this guy's a big dog because this is cool stuff, and went and was like, all right, I'm following him immediately. So y'all go follow Hunter. I'll put his links to everything, the site, the Twitter handle, the company handle, all that will be down in the show notes below. Thank you for doing this. This is a lot of fun, and congratulations on doing so well in the first year. That's amazing. And dear listeners, thank you again for listening to the nerdiest podcast that has ever existed, that is both a delight and hopefully an education for y'all. So let me know what you think. If you know of anyone similar to Hunter who is very smart and wants to talk about a bunch of nerdy stuff, send them my direction. Check out databaseschool.com for all of the episodes and for Introduction to Postgres, which is now out for free. So go check out databaseschool.com and I don't know, do anything else. Like, subscribe, all of that stuff. Thank you for listening. And Hunter, thank you for being here.